98% of the time, simply by going and watching these YouTube videos and then practicing a lot on his own, he became a champion in throwing the javelin. So what this tells you, I think, is something very important, which is that you can learn a lot of different things online that you never thought you could learn before. So I want to give you a little sense of my own background. I grew up moving all over the place. So by the time I was 15 years old, I'd lived in 10 different places. And the thing is that math is very sequential. So when I was 7 years old, from Lubbock, Texas to Chelmsford, Massachusetts, they left me in the dust. I couldn't get it. They were very far ahead of me in the multiplication tables. So I just thought, I guess I don't have the math gene. I gave up and I fluked my way through elementary, middle, and high school math and science, which is a little ironic since I am speaking with you here today as a distinguished professor of engineering. So one day, one of my students asked me, how'd you change your brain? How did you go from this math loathing person to become a professor of engineering? And I thought about it. I mean, I was this little girl who I loved animals and knitting and weaving and all those kinds of things. I knew I could never grow up and do anything technical. But I thought, what can I do? And I thought, I think I can learn a new language. I would like to learn a second language. Now, for most of you, many of you, you speak an additional language. But for me, I thought it seemed really fascinating. It's something I really wanted to try. So I couldn't afford to go to college and study a language. I didn't know how to go about doing it. But I found out there was one way to learn a language and actually get paid for it. And that was to join the Army. So there you see me looking really nervous, about to throw a grenade. And if you knew how clumsy I am, you would know why I look so nervous. But I did learn a second language. I learned Russian. Wish I'd learned Ukrainian, but in any case, I ended up working out on Soviet trawlers up in the Bering Sea. And I just loved having new adventures and seeing the world through new perspectives. So I also ended up at the South Pole Station in Antarctica. And that's where I met my husband. So I like to say I had to go to the end of the earth to meet that man. But here was the trick. I was 26 years old, was about to get out of the Army, and all of my colleagues were trained with technical sorts of issues. Many of them had been trained as engineers. And I couldn't get a job offer, but they were getting job offers right and left. And I thought, you know, I'm supposed to be open to new perspectives and new adventures. Why don't I see if I can have a new adventure, not of a place, but of the mind, and see if I can change my way of thinking about how to learn. And let's see if maybe I could learn in math and science. So at age 26, I went to the university and I started with the lowest possible math, which was remedial high school algebra, and slowly began climbing my way upwards. It was not easy, but if I'd known then what I know now about how to learn effectively, I could have made it so much easier on myself. So what I want to share with you here today is some information about how your brain learns and how you can use it to learn most effectively. So we should start out with sort of a simple idea. What's the basic building block of the brain? It's the neuron. And I know what you're thinking. You're thinking this is the part of the talk where she gets into the heavy, boring scientific stuff. So let's spice it up a little bit. we're going to use a metaphor for a neuron. And this metaphor is a space alien. So you see below, there's three kind of like legs on the space alien. And those, on a real neuron, those are called dendrites. And they have these little spikes that stick out of them, kind of like toes. Those are called dendritic spines. And the last little important piece of information is just that neurons have arms that reach out that are called axons. That's really all you need to know as far as nomenclature goes. And what neurons do is actually quite interesting. They just love to reach out and tickle one another's toes. So what they're really doing is they're reaching out with their arms and they're sending an electrical signal that jumps across that little gap called the synapse and moves on to the next neuron. So what you're really doing when you're learning something is you're simply making connections between groups of neurons in long-term memory in the neocortex. So this means whatever you're learning, whether it's that you're learning how to take a dance step, how to do something during drill, how to conjugate a verb in a foreign language, how to take a derivative in mathematics. Whatever you are learning, you are simply making connections in long-term memory. For years, you've heard from people saying, oh, you don't need to memorize that. You can always look it up. Now they're finding that, yes, you actually do need to memorize or remember key items, because if they're not in your long-term memory, you haven't learned them. Now, how do you put them in long-term memory? How do you strengthen those links that you're creating? Through practice. The more practice you give, the stronger and richer those links become. Ultimately, these links are kind of like a necklace. They strengthen with practice, and you can much more easily pull them to mind when you need to. So I'm going to pose a question for you here. What is the most powerful technique that helps you to learn most efficiently? I'm going to give you 4 options. So first is rereading, just what it sounds like. Highlighting or underlining, most of us have done this as well. Retrieval practice or recall, that is like using flashcards. Or is it a technique called concept mapping, which is where you write down key concepts and see how they tie together? So hopefully you have in mind which one of those 4 you think is most effective. And we shall go and look at the answer now. Are you ready? The answer is retrieval practice. And this is so much better than any of those other 3 techniques that you can't even compare them. So why is retrieval practice? What is it and why is it so powerful? When you learn anything, you are actually creating weak sets of links in long-term memory. So like right now, you've got some really weak sets of links. But if after this talk, for example, you pause and you ask yourself, what was the main idea that she was talking about? Or what were the key ideas? And you retrieve those key ideas. Each time you retrieve them, you actually strengthen those sets of links. And not only that, you're not only strengthening them, you are helping consolidate them. That is, tie them in together with other knowledge. And you're really making it so that this information becomes much more accessible in your mind. So what happens if you don't retrieve? If you, let's say you are taking a course and then you watch a couple of videos and then you let it sit for a couple of weeks because you have other things you're doing. And then you return to it the night before a big test. Well, since you haven't looked at the materials for a couple of weeks, what happens is you have not used those little synaptic connections, those dendritic spines, and your little synaptic janitor just sweeps those spines away because they haven't been used. That's why you can sit down to study for an exam that you haven't looked at the material for quite some time, and it's like you're having to start fresh because you actually are. Some of those dendritic spine connections have melted away because you haven't used them. And we can see this in a light microscopy image. This is an image of you're a budding neuroscientist now, so you know this is part of that leg of a neuron that's coming out called the dendrite, and it's got these little dendritic spines that are coming off of it. Can you imagine what is going to happen? So this is a living neuron before learning and before sleep. What do you think is going to happen after learning and after sleep? Do you think that dendrite is going to maybe get thicker or more dendritic spines on it? Here we go. This is the same living neuron after learning and after sleep. And if you look, there's these little blue triangles wherever these new dendritic spines have emerged or changed. So sleep itself helps promote learning and strengthening of those neural connections, because as you're sleeping, there's hundreds and hundreds of electrical signals pass along the route, jump the gap with neurotransmitters, and strengthen by virtue of the fact that they practice so many times going over that route when you're sleeping. One thing that you can do to help with your learning is right before you go to sleep, get in mind just what it is you're trying to remember or understand, and spend 2 or 3 minutes. Don't do your studying at that time. Just get it back in mind right before you go to sleep, what you're trying to learn or understand or remember. And what that'll do is that'll signal your brain that during sleep, you want it to be practicing with that particular set of material. When you wake up, if you have a couple minutes, do the same thing again. Practice again, retrieving that information. You'll really be able to strengthen those neural connections much more quickly and effectively that way. So there's also, of course, a part of any kind of retrieval practice is the idea of spaced repetition. In other words, if you're going to retrieve, you want to do it retrieving over a number of days. And each time you retrieve, as you can see, these neural links get stronger and richer and thicker. And it's not just because you've practiced at the time. It's that when you practice and then you're able to sleep at night and practice and sleep at night, you get like twice the bang for your buck. So if you have 5 hours to study, use 1 hour per day over 5 days, rather than say 5 hours all in one day, because that sort of cramming makes it so that you don't have strong connections and they will die away, and you won't be able to use the material as effectively. Let's say you're studying a different language. If you spend a number of days, a little bit of time over a number of days, you will really be able to create a solid neural structure. If you cram for 5 hours in one day, that structure is just not going to stay with you. It's a little bit like building a brick wall. If you take your time, you lay a layer of bricks, mortar, bricks, and then you let that mortar dry. It takes time, but you have a good solid wall. If you don't do that, you have a very poor foundation for your learning. So I like to think of weightlifters and how it takes them time. And indeed, neural tissue as well as muscular tissue are both excitable tissues. And so that means it takes time to build those tissues. Now, learning is a lot like baking a cake. It has many different facets to it. And I just want to touch base on an idea that would have helped me a lot when I was a 7-year-old and I was doing poorly in mathematics. And this relates to the two different modes the brain has that it thinks in. And for rough purposes, I'll call one the focused mode. This is what psychologists call the task positive network. The second mode, I'll call it the diffuse mode because it's this more relaxed set of neural states. Neuroscientists call this the default mode network, and psychologists call it the task negative set of networks. But really, it's the set of connections in your brain that arise when you're not thinking about something. So to better understand these two very different modes, we're going to use a metaphor. And the metaphor we're going to use is that of a pinball machine. So this is the basis for a lot of today's some of video games from today. And if to play pinball, all you do is you pull back on a plunger, a ball goes bouncing out, and that's how you get points. So what we're going to do is we're going to take this pinball machine, that table, and we're going to put it right onto the human brain. So there we go. There's the pinball machine on the brain. And you can see that what's happening is you've got these rubber bumpers and they're very close together. And this is representing sort of the matrix that your thought moves in, that your thoughts move in. And your thoughts you can see that in focus mode, those little rubber bumpers are very close to one another. So if you think a thought, like let's say what's 22 times 74? And you try to multiply 22 times 74. If you know math already, it moves along, your thinking moves along these pathways that you've already laid by virtue of the fact that you've already learned how to do multiplication. So focus mode often has patterns of things we know how to do, like speak a language or write, maybe type, just things we're skills that we might have. But what if you're trying to learn something completely new, so you don't have a pattern already laid? Let's say that you know multiplication, but you don't know division. So how do you learn division? I mean, you don't know where to put the pattern, how to pull it out, how to use it. In fact, when you first start your first big division problem, what you'll often do is you'll kind of, you'll be thinking you're trying your first division problem, but you can't help it. Your mind just slithers back up to multiplication because it's easy and you did a lot of it. And so those first division problems can really be a struggle. In fact, sometimes you just can't get the right answer. You close the book, you get up, you walk away, and when you do, it actually opens that different way of thinking. So when you are relaxed, when your mind gets off that problem that you're really stuck on, it opens that diffuse way of thinking. Now, in this way of thinking, you can see your thoughts move much more widely. They can't think in that careful, compact, close pattern like they can when you're in the focus mode, but they can at least get to the new place you want to be in when you are trying to understand and solve a new problem. So learning often involves going back and forth between focused and diffuse modes. You can't really be in both modes at the same time unless you're taking certain forms of mushrooms, and I am not advocating that here. Although I should say that those with attentional disorder problems, so if you have ADHD, that is a very interesting phenomenon because it turns out that you kind of have fewer or less dopamine neurons. And what that means is you don't quite have as much dopamine in your brain as other people might. And that means when you activate your focus mode, you inadvertently can activate your diffuse mode. So that's why you can seem rather flighty, right? You're trying to pay attention, but at the same time, you're being distracted. But it turns out that this may be a challenge. Indeed, it is a challenge, but it has hidden advantages. There's a lot of creativity that has been found in those with attention deficit disorders. More than that, when you do focus on something, you can hyper focus. You can focus even more than a typical person might be able to focus. It's just that something has to be something that really draws your interest. So that's, those are the good points and the bad points of ADHD. Now, we should turn now to another issue that is a challenge for me, including me, which is procrastination. And I do have to say, wherever I go around the world, procrastination is one of people's biggest issue everywhere. And that should be no surprise, because what happens when you even just think about something you don't like or don't want to do, it activates a portion of the brain called the insular cortex that makes you experience pain. So the brain, naturally enough, does this kind of thing. It says, I'm thinking about that homework I'm supposed to be doing, and it doesn't make me feel good. So I'll just turn my attention to something more pleasant, and I will feel better almost instantly. And that's exactly what happens, except that you've also just procrastinated. So since I'm an engineer now, we're very practical, cut to the chase. I will tell you the biggest helpful tool for you to tackle procrastination, and that is the Pomodoro Technique. This was invented by an Italian, Francesco Cirillo, in the 1980s. And I can say, so I teach a course with my co-instructor, Terry Sanowski, and I am sitting right beside his office here at the Salk Institute right now. And this course, we've had well over 3 million students. So when I say I have heard from tens of thousands of people about how they find this Pomodoro technique to be incredibly helpful, believe me, it is incredibly helpful. So what I love about this technique is it's super simple. So all you have to do is first turn off all distractions. So no pop-ups on your cell phone, nothing popping up on your computer. Good luck if you've got a 2-year-old at home, but do the best you can. Set a timer for 25 minutes. Work in a focused way as effectively as you can for 25 minutes. You will naturally have thoughts that are like, what about this? Make a little note if it's something, but as soon as you catch your mind wandering, simply bring it back. And then in the final minutes, so after you've done your 25 minutes, give yourself a 5-minute relaxing reward. And by that, I simply mean maybe listen to a favorite song, make a cup of tea, walk around. Sometimes physical movement is a little bit of its own reward. But for heaven's sakes, don't go back into focusing on something like saying, I've got my cell phone here. Oh, let's just see if I got a text message. Because what happens is you fall right back into focus mode. So what you want to do is a clever mixture of 25 minutes of focusing, focus mode, and 5 minutes of diffuse relaxation, mental relaxation. So a lot of times people will like to do they'll do 4 Pomodoros, each separated by 5 minutes, and then they will, at the end, do a half an hour break. So that's a very popular way. There's all sorts of Pomodoro apps. Just go take a look and you'll see. So I just want to very quickly talk about dopamine, which is that molecule that can make you feel really good. We have it squirting all over the brain all the time. Turns out that dopamine, if mice that have damaged dopamine systems can't learn anything new. And indeed, dopamine, it seems, is a key to helping you learn effectively. I'll give you just a quick idea of what I mean by that. Let's say you're trying to solve a problem. So you try a certain way, no solution. You try another way, no solution. Try yet again, no solution. And you try one more time and you get the solution because you were curious about that problem. You get that, solved it, eureka, and dopamine squirts in those exact locations of the most recent path that has been used. And that is how you learn those new threads of links in long-term memory that are behind our ability to learn. So as we're closing up, I just would like to say that we know that neurons learn by making connections, and if you don't make connections, they will wither away and die. So new learning actually helps with the promotion of and growth of new neurons. And it turns out that new neurons boost your spirits. So thank you for being with me here in our VETS Hackathon and for boosting your spirit, and happy learning to you always. It's my pleasure. Thanks for the invitation and happy learning again.
Oh, were there any questions that we could forward to her or email to her down the road? Okay.
So answer.
Before we do the teleport, could I add? Yeah. So as far as for those who are just coming in, or just as a reminder, again, today the emphasis is just try to acquaint yourself with the different folks who are here, and get a feel for some challenges or topics that really attract your interests. Think of a trajectory rather than a specific destination at this time, and know that you can iterate. Your ideas may change over time. Tomorrow there's going to be a huge block. I don't know if you all saw, but like from like